Okay, so we have talked about how to determine if something is a proportional relationship. We talked about finding the constant of proportionality. Now we're going to put those things together and compare proportional relationships specifically in different formats. Okay, so we have example one. Mira is researching cruising speeds of different planes. Which airplane has a greater cruising speed? Now, I do want to point out that when we talked about our tables, when we talked about our equations and our graphs, we said to take y over x. So if we look at our table here, okay, it doesn't have x's and y's. We can usually assume that the first one is going to be x and the second one is going to be y. And we can verify that that's supposed to be the case here because if we look at our units, y is the distance in kilometers and x is the time in minutes. And if we look at this, I'm going to look at this piece, the kilometers per minute. Okay, if we think about what that means, that is the speed. Okay, so when we set up our ratios that way with our kilometers on top, our minutes on the bottom, and we end up dividing it, okay, that is going to be the speed. So that's why this works. Okay, the distance over the time. So in this particular case, it didn't say it's proportional. So we should probably just verify quickly that it's proportional. So if we do all of our y's over x's, it'd be 40 over 5, 120 over 15, 240 over 30, 360 over 45, and 480 over 60. And you would divide them all with your calculator. Okay, you would find that all of those equal 8. Okay, so what that's saying is this Cessna 310 that's represented by the table, okay, its speed is 8 kilometers per minute. Now we're going to look at our graph, okay, and we're going to find an ordered pair that works nicely. Okay, so we have, once again, our y-axis is the distance. Our x-axis is time in minutes. So it's going to be distance over minutes, kilometers over minutes. Okay, and we need to find a good ordered pair to use. And I am thinking that maybe this point right here would be good. Seems to crisscross a nice spot. There's a couple of them, actually. I'm looking at it. This one's nice. This one's nice. So we have a couple places we could use here. It does tell us that this 0.1 comma r represents the unit rate, which is really what we're going to find, but I'm not 100% sure what that number is. It's not crisscrossing at a nice spot. So I'm just going to choose one of those other nice numbers on the graph. So this ordered pair right here would be 2 comma, and it's crossing here, which is halfway between the 20 and the 40. So that'd be 2 comma 30. And now if I'm doing y's over x's, okay, or kilometers over minutes, that would be 30 over 2, which divides to be 15. So this Boeing 747, is going 15, trying to erase, but it's not. There you go. 15 kilometers per minute. And if the question's asking us which has a greater cruising speed, that would be this one, the Boeing 747. 15 is higher than 8. Example 2, we have a graph representing the rate at which Marlo makes origami birds for a craft fair. The equation y equals 2.5x represents the number of birds y Josh makes in x minutes. Who makes birds at a faster rate? Okay, well, if we look at the equation, we have y equals 2.5x, and this is for Josh. It says x is the number of minutes. Well, we said that this is the constant of proportionality, okay? And we can even say like, oh, if x is 1, that is 1 minute. He would have made 2.5 birds in 1 minute, so that makes sense. So Josh is making 2.5 birds a minute, which actually seems pretty quick. If we go look at Marlo's graph, okay, we have a lot of good points, I would say. Let's choose this one right here. So his point would be 10, comma 2. Okay, and if we take y over x, which once again, y is birds and x is minutes, so we're figuring out birds per minute, and that would be 2 over 10. That would actually be 0.5 birds a minute. So he's actually pretty slow at making these origami birds. So who would make birds at a faster rate? That would be Josh. He's making 2.5 a minute compared to Marlowe's doing 0.5 birds a minute. Just to show you an alternate method, in these types of questions where it's not specifically asking you to find, hey, what's the constant proportionality, just asking you to compare two different things, okay, you could also just say, like, let's pick a common time in this case, since we're talking about minutes, and see how many they would make in that time span. Okay, so if we did, I don't know, 10 minutes, okay, in this case, that would be the x to plug into our equation because it said x was the number of minutes. So 2.5 times 10 would be 25 birds. We already know from our graph that at 10 minutes, Marlowe only made 2 birds. So that's another way. Pick a common time frame, see and see how many they would make in that time frame for both of the scenarios. That also works in this situation. Either way, Josh is doing a whole lot better. Okay, we're going to go to the second page of notes. This one says example 3, the graph represents the rate at which Daniel earns points in his video game. The rate Brianna earns points in her video game is represented by the equation y equals 2x. So we got Daniel's graph, and Brianna is going to be y equals 2x, where y is the number of points, x is the time in minutes. So once again, if x was 1, okay, 2 times 1 is 2, it's saying she's making gaining 2 points in her game per minute. So the COP is how much she's earning per minute. Okay, it's also the unit rate, really. So really, COP, the same thing as unit rate. Okay, it's essentially how much for 1. I'll add that in here since I have a little bit of room. So COP is the unit rate, how much for 1 of whatever your X is. Okay, so Brianna is earning 2 points each minute. Okay, based on her equation. We need to look at Daniel, okay, where we have, once again, a bunch of nice points here. So this one will be 1, 3. Okay, and if we do our ratio of y over x, that would be points over minutes using those labels on the axes. And if it's 1, 3, the y is 3, the x is 1. Okay, Daniel is earning 3 points each minute. So if it's asking who's going to reach 100 points first, well, it's going to be the person that's earning more points each minute. So that would be Daniel. And our last one, we have the graph represents the cost per ounce of a granola cereal. A 15-ounce box of a raisin cereal costs $3.90. Which cereal costs more per ounce? Okay, this one's a little bit different because we have our graph, but we don't have a table or an equation to look at. But we do have a scenario here. And it does say costs more per ounce. So the way we're going to set up these ratios is going to be cost per ounce. And once again, for our graph, if we look at y over x, the y label is cost, and the x label is ounce. Perfect. Y's over x's. Okay, let's start with the graph because that one's there. I have when x is 5, I'm not sure what the y is. I'm not sure what the what the y is when x is 10. But at this point up here, that looks like a nice point. So that ordered pair would be 20. Even though it doesn't say it, that y value would be 5. So it's $5 for a 20-ounce box. Okay, I'm going to do this one a little bit differently. Instead of just dividing, what's really going on here is we're trying to figure out how much for 1. So if I divide 20 by 20, that'll give me 1. And that's why this works out to be 5 divided by 20. And 5 divided by 20 is 0.25. So this is costing essentially 25 cents per 1 ounce of cereal. So now we're going to take that scenario. It says a 15-ounce box costs $3.90. So the cost is on top, $3.90 for a 15-ounce box. We want to know how much for 1. So if we divide the 15 by the 15, it gets us that 1. We're going to do 390 divided by 15. I'm using my calculator. And we get 0.26. So this raisin cereal is 26 cents per ounce. So comparing 26 cents an ounce and 25 cents an ounce, the raisin cereal is going to be more expensive than that granola cereal. Okay, so when you're trying to compare these, okay, essentially you're finding that constant of proportionality, whether it's in the equation and it's just that number, or if we have to set up those ratios of y over x, okay, or if it's a scenario where we kind of just look to see, you know, what are the two pieces we're comparing, let's set it up that way. Okay, and then you find that unit rate, you find that constant proportionality and compare.